My name is Scott Paul. I will be the moderator for the next session this afternoon, but I'm faculty at the school. I'm going to give you a little bit of the admin for this building. We have exits located at the front here and through the back. The coffee session will be held outside here in the lobby. The restroom is located outside to the right, and if you follow around the path, covered pathway, there's a doorway, and all the way to the end on the left are the restrooms. In the event of an emergency, there is placards located on the bulkhead back there for the emergency evacuation location. It is located immediately to your left near the road in case of something like that. So without any other information, this is Captain Bird.
Good morning, everyone, and welcome back to our session. So let me just get ready to the session is presentation on common themes of incorporating enabling technologies and fusing elements, all in a structured way because of the increasing reliance on data systems providing authenticated information when we need it. Rear Admiral Cropper had talked yesterday about some of these points in his opening remarks, and I'm on to moderate the discussion. We have 6 presenters today, and our first one is David Conlon. And David will talk about the Maritime Cloud, and that it is an enabler of seamless information exchange between various systems across different communication links in the maritime domain. David.
Thank you. My name is David Hammer. I work with the Ames Maritime Authority in the area of e-navigation development. I've been involved in test bed implementation in the efficiency project, and I'm currently involved in the XCs project. I've also been part of the Mona Lisa 1 project. I would like to introduce a proposed technical infrastructure for the e-navigation concept, and it's called Maritime Cloud. The background for the infrastructure is that, well, firstly, the overarching e-navigation architecture, as decided by the IMO, assumes that there's a seamless data exchange between maritime actors on board and ashore. Secondly, the testbed experience that we've had at the EMA with potential e-navigation solutions shows the need to have technical infrastructure to support this data exchange. So we need a common framework that will enable all the actors within the maritime community to communicate and exchange information seamlessly. So early on, a number of high-level requirements was identified, which has driven the development of the infrastructure. So we needed communication means to support and meet all the requirements of e-navigation. We've had some experience with AIX before, and we've tried and tested various other communications. But we need some kind of new communication needs to meet all the new requirements. The ability of service consumers, they must be easily able to provide the services in a given area. So if you have some data you wish to put out to the user, into the maritime community, it must be easier for the end provider to provide it. On the other hand, that's what goes around. So consumers must be able to easily locate them, and providers must be able to provide them to the end users. All the maritime actors within this need to have a unique ID, calling this maritime ID with an attached attribute such as role or nationality, or you could have a bunch of different things that compose this ID. And it's not always enough because that can change depending on the ship, and we need some sort of unique identifier for each character or each actor within it, because it's not just restricted to ships alone. Finally, and we just touched about briefly yesterday, cybersecurity. You need to have the infrastructure to provide all the security for secure communication. So you need to support authenticity. That is, you need to guarantee who you're talking to, and you know that the person you're talking to is actually who they claim to be. You need to guarantee integrity. That is, the data you're receiving has not been altered by a third party. And finally, confidentiality. So when you're receiving some data, nobody else could swoop in and listen on that exchange. So our solution to meet these requirements, among can be seen as a refinement of the overarching e-navigation architecture. But though it is important to make clear that it is not a detailed ship or shore architecture, but rather a component in the common shore-based system architecture and the ship-side architecture. The maritime cloud consists of three key components. You have the communication needs, that is, how to exchange data. You have a maritime identity register, how to identify actors and solve security concerns. And you have a maritime service portfolio registry, how to locate provider services. The first key component is communication. Basic communications needs are, of course, essential for a communication framework. Currently, we have one general purpose basic communication universally available in the shipping, and that is AIS. And in some cases, we have some commercially available TCP/IP or standalone text-based or limited data packet transfer system via satellite or high frequency. Though it is questionable if AIS will be sufficient to support prioritized e-navigation solutions. So yesterday, Hagen mentioned that they've identified several services that they think will be part of the e-navigation first step portfolio. And we've done some tests within the DMA where we tried to use AIS as the main carrier, and we quickly ran into several issues of how much data can be packaged into the AIS, is there any security concern to that, and finally the AIS is simply not designed to handle something like e-navigation, and any attempt to sort of overload it will need and can be destructive of its existing functions. However, there are some new dedicated communication systems like the NAVDAT or DDES, but it needs to be developed and demonstrated before they can be assumed. So they're not really available in the short term for e-navigation. The cloud must be able to utilize all these different communication technologies as they become available. So we cannot tie ourselves down to a single technology and say this thing, because e-navigation is some way off, but we need to work on it already now. And if we tie ourselves down to a single protocol now, we're going to be locked in. And we need to make sure that it's future-proof, because who knows where we might be in 2017 or further in. In the need of new communication means, and as we anticipate, Internet is becoming an important communication need in e-navigation. We propose a new geo-aware messaging protocol implemented on top of TCP/IP as part of the maritime cloud. We can also call that an overlay network to the Internet. The protocol works by connecting actors to one among a number of maritime messaging servers organized in a peer-to-peer network. When connected to the messaging server, the actor can send messages, and at a protocol level, the actor will regularly sense the position, such as in the case of a mobile actor like a vessel. This allows the server to maintain a geographical awareness that they share among each other in a distributed fashion. The geographical awareness could possibly be supplemented by AIS data. The protocol requires an internet connection, and in some cases a number of connections are available, so the selection could be based on least cost routing or other prioritizations. However, internet connections on vessels are often unstable, so in order to receive resilience, which is an important part of it, the messaging service will implement store and forward by caching messages that cannot be delivered and send them once the packet reconnects. Messages will have a time to live indicator that the sender sends out or how long the message is valid, and the cache will have a prioritized queuing to send the most important messages first. So for instance, if you're a vessel and you're listening for routing in an area and you lose connection, and then another guy is sending out some routing information, as soon as you reconnect and you reestablish the connection, you're going to get the messages. So nothing is lost, because it's always hard when you need to maintain that everybody knows all the information available, but they might not connect at all times. Geomessaging protocol allows actors to send messages directly to the other actors without any range limitation. The actors could be located at the opposite side of the globe. Geographical awareness enables geoconsting, that is, actors can broadcast to other actors within a specific area. Actors can listen to a specific area or a specific service. For example, a non-mobile actor like a BTS sender or a closed STCC senders will not have a position, but will specify an area of interest for which they will receive messages. When we're looking at geoconsting, we see that as an implicit feature of many radio-based communication systems. The area is not specified but given by the physical capabilities or limits of the communication system. For example, AIS, where the area will be bounded by the range of the VHF signal. In that sense, we can use the geomessaging protocol as a way to emulate current and future communication systems. This will allow us in test beds to identify communication requirements for potential e-navigation show you a little about how it works. So you have all the vessels here. You have this guy here. He's broadcasting some information in this area here, and we have another guy up here who's listening in this area. So these two can't see each other because whatever he's broadcasting will not be relevant to this guy. You don't want to cloud it. But then you have a VTS server who's listening to all of this, and he'll be able to see anything that this guy is sending out or that guy. The second key component in the maritime cloud is the Maritime Identity Registry. It's a distributed registry maintained by a number of identity brokers in a peer-to-peer network. All actors in e-navigation will obtain a maritime identity in the Maritime Identity Registry. Similar to a call sign or MMSI, but not tied to a specific role or specific technology. So it needs to be universal and it needs to not just be tied to a single thing because actors can be many things within this maritime cloud, not just restricted to vessels. All actors can also obtain a digital certificate to allow to implement security in the cloud using a public key infrastructure. The certificate will have a variable trust, so it might be easy to obtain a certificate with a low trust, but obtaining a certificate with a high level of trust requires a process in which the actor's identity is determined securely. Actors providing services will need a certificate with a high level of trust because you need to know and you need to verify that whoever you're relying on, if they're sending you information, you need to verify that this information is correct and that you can trust it. This completely resembles obtaining a certificate for a website in the internet, and is also used in the financial sector to verify identities among institutes. The registry contains some information about the actors. You can have some static information like contact information, call sign, communication capabilities, and so on. The registry could also contain dynamic information, which is considered integral for e-navigation, for example, position and maybe large information. This information would not be freely available to any agent within it. So if I'm just another resident, I can't see all the specific details of a specific vessel. But if I'm an MRCC authority, I will be able to pull out all the necessary information about a given vessel and its capabilities. So if you're doing a search and rescue, you know what are each vessel's capabilities. The third component is the Maritime Service Portfolio Registry. It's a distributed registry maintained by a number of service brokers in a peer-to-peer network. It contains a service specification register and a service instance register. The specification of the service is envisioned to be located in the product specification of the ISO S100 GI register. The service instance register are going to lead the service, that is the specification details of the service provider, that is their identity, who's giving you the service, and the area or like junction where the service is being offered. And then metadata like policy and service endpoints for the different communication needs are also important. Service providers maintain their provided services in the service register. And that enables service consumers to pay brokers for the available services. All actors can act as both service providers and service consumers. A ship could, for example, provide sensor readings as a service. In this case, the area where the service is provided will be relative to the ship's position. Its Maritime Service Portfolio Register is intended to span all maritime services, not just electronic services. An important enabler of the maritime cloud is the Almanac. It's an offline version of the public part of the Maritime Identity Registry, the Maritime Service Portfolio Registry. It's comparable to an advanced electronic white page reality phone book. So actors can either use their registry directly using web services or the internet, or they can have the offline Almanac, which needs to, of course, be updated regularly. They can either download this when a connection is available, for instance, on the port, or they can carry it on board on a physical medium. This resembles how ENC charts keep up to date. Having the Almanac offline allows use of identity and service content. That is, for example, other actors can be authenticated, data can be encrypted for full confidentiality, contact information and other information for actors can be located, provided services and area can be found, and so on. So to summarize some of the consequences and highlights of the maritime cloud, it will support the notion of e-navigation as an infrastructure and services seen as apps. Services will be able to evolve dynamically and be provided by all maritime stakeholders, including commercial. It builds on existing technology, therefore it can be cost efficient. The security solution is proven and used today, for example, the financial sector. Having identities that can be authenticated allows for data sharing policies to be enforced. So instead of AIS, where it's sort of like shouting into a room and hoping someone is picking up, you can enforce exactly and see exactly who's getting this information using the service and who has access to it. It facilitates seamless transfer from existing to new communication means, and that's an important part because e-navigation is not just a complete revolution where we throw out all old systems and put up some new ones. It's a slow gradual, and you need to be able to maintain the previous ones while introducing the new concepts. Availability and scalability is addressed by the peer-to-peer architecture. Testbed will early on be able to utilize the Maritime Cloud as a communication infrastructure, and they will allow them to evaluate potential e-navigation solutions and to involve and mature the infrastructure itself. Finally, the concept has been submitted to the IMO e-navigation process as a proposed infrastructure that will support e-navigation in the short and in the long run. So lastly, the status and the way forward. The infrastructure is currently in progress in the AXIS project, where the Maritime Cloud will serve as to test that infrastructure. We try to take an agile approach, in which while the concept is continually demonstrated and evaluated in practice, that means that the conceptual and practical work is progressed in parallel. All the source code developed will be available as open source for evaluation and collaboration will be available online. A different track that has to be progressed is political aspects, that is, possible governance structures, legal, cost, and operational issues. It is important to note that the cost of the distributed architecture of the cloud will be able to accommodate many different governance structures. Thank you. I don't know if you're doing questions later or...
We'll do questions at the end.
Okay.
Our next speaker is Derek Arnold.